All right, so with 3.2, we're going to go over quadratics in standard form. Okay, so we did vertex form, which is, of course, oh, that's Q, not H. Okay, so that's your vertex form. Now we're going to get into standard form. We covered this one again in pre-calculus 20, or sorry, foundations 20. And all it is it just looks like this. Okay, or if it's written as a function, it'll look like that. Now, standard form has its place as well. It gives you some information about the graph with it or the function, but vertex form tends to have the better information, like the vertex, which is a lot more easier to work with. And pretty soon, by the end of this week, we'll learn how to go back and forth between the two. They become interchangeable. It's actually pretty straightforward. People tend to like it, so it's not too bad. The big things to take away from standard form are the A value and C. B doesn't give us a whole heck of a lot. It determines where the graph is going to go, but we don't really get into a whole lot of working with B, so I'm not going to stress it a whole lot, okay? Just know that it influences where the graph goes. It'll do some kind of shift or translation, okay? Any questions? You guys kind of remember this? Remember examples, could be anything like x squared plus 3x plus 2. Here your A is 1, B is 3, C is 2. Your A value can never be 0, okay? Because if that happens, then you don't have an x squared, and it's not a quadratic. All right, and it is possible, though, to have a B or a C value that's 0. Okay, like this. That's totally a quadratic there. All right. It just means your y-intercept is at 0. Okay. Could you guys tell me, just based on this one here, how many x-intercepts the graph will have? Think about where the y-intercept is.
2. 1.
Where's my y-intercept?
Oh, yeah, because your vertex is the origin.
Right. Because my y-intercept is at 0.
Yeah.
Like that. Okay, good. All right, cool. So let's look at this guy here. You can't really tell with this, but here's x-intercept. That's the y-intercept, or the y-axis and the x-axis. Okay. So with this one here, if we were just looking at the graph and we wanted to come up with a few things, we could just by looking at it. Like here's my vertex here, and that's at 1 down and 2 over, so that's at 2 and -1. Okay. My y-intercept is at 1, 2, 3. There's 3. My x-intercepts are at +1 and +3. Okay. My axis of symmetry, remember, that's just the x value of the vertex. My domain, can you guys remember what domain is?
Yes. Squiggly line.
Squiggly line.
X.
Yeah.
Line.
Yeah.
Another X.
Yeah.
And then the E thing.
Element of a real number.
And then a squiggly. And then a squiggly. Yeah.
Very good. All right. Now, if we look at the range for this guy, we can see that my vertex is the minimum value. So all my y values are going to be bigger than or equal to my vertex. Greater than or equal to
2, -1.
-1. Right. Okay. Now, how does this help us with standard form? At this point, it doesn't, but there's a nice little review to do. Okay. Good tip of information that I'm going to give you guys here about standard form, though. I just want to make sure I write down the equation right. Because this will help you a lot. Whenever you're given standard form, you can actually solve for P. Okay, the x value of your vertex. P just equals negative B divided by 2a. Every time. Okay. And then once you have your p-value, you can plug that into your equation in standard form, and that'll give you the y value. So you can solve for p and q. Okay. So then, in theory, what you can do is you can factor for your x-intercepts. You can get your y-intercept because it's given to you, and then you can find your vertex. Okay. Any questions about that? All right. I can't remember if I give you this formula on the test or not. You might actually have to memorize that one. Negative b divided by 2a. It's not a big one. Okay. So now let's solve this stuff based on what we're given here. Okay. So the vertex, that's the first thing I would ask for. Once you know that, everything else kind of falls into place. So to find the vertex, we know that p equals negative b over 2a. So my b value here equals negative 7. So I put negative b in there. So negative 7 is
Positive 7.
7 over 2a. My a value equals 1.
3.5.
3.5. Very good. Vertex starts. And now to find the q value, I take the 3.5 and I just plug it in for x. So, like that. And you just use your calculator. You can probably punch it all in one step.
Negative 2.25.
Negative 2.25. That sounds about right. Yeah, good. So there's your vertex. Y-intercept? Anyone? Very good. That's just my c value. It would be at technically 0 and 10. All right, x-intercepts. Am I going to have 1, 2, or none here?
2.
2, right? Because my vertex is somewhere 2.5, right about there. My graph opens up, so I'm going to cross there twice. So now I know I'm going to have 2. Do you guys remember how to find them? We could just factor, okay? For the first little bit here, pretend like you haven't learned the quadratic equation. Because technically I haven't shown you in this course yet. So you would just factor it, right? 2 brackets. Factors of 10 that add up to 7. What times what gives me 10?
5 and 2.
5 and 2, right? So my x-intercepts would be at 2 and 5. You still with me, Carson? Your eyes look like they're getting heavy.
I'll feel you.
Oh yeah? Need some water? Want your phone back? Good. Sorry, that was a little low. 2 and... well, I think I do that one. Yeah, I totally did. 3.5 over here. Ignore that other dot. That was a warm-up dot.
Yeah.
All right, just getting everything going. Axis of symmetry. I've already solved for p, so I know it. X equals 2.5. My domain.
Please equals.
What?
Huh?
All right, and my range. I know my y value is a minimum because my graph opens upwards. So y is going to be greater than or equal to negative 2.25. All right. Yes, it's messy. It's okay. Yours can be messy too. Your R's and your E's don't have to be artwork. Then if we were to graph this, now this goes up by 1s, 2, 4, 5, so 10's up here somewhere, so I'm not going to touch my axis. Something like that.
That's good.
Thank you. Okay. How do you guys feel? How do you guys feel about this so far?
This is good.
Okay, this isn't so bad, right? Like I said, even though we're taking the harder math course now, after doing Foundations 20, this gets easier. Okay, I promise. It's not as bad. Oh, I'm kidding. The hard problems are pretty bad. But it's actually not so bad.
Okay, so what?
It's fine. I was like, I'm kidding. The word problems are horrendous. But I'm like, no, I'm just kidding. They're not so bad.
Oh, I didn't hear what you said.
Yeah.
Oh, sorry. I kind of mumbled.
It's okay.
I thought it was super funny and I got excited and just.
I would have moved, but I just didn't.
That's all right.
I'm not so worried.
Want some vitamin C? Okay.
It's also known as an orange.
Well, you can call it what you want, and I'll call it what I want. All right.
You know you're still recording.
Yeah, I know. It's all right.
A long time.
Have a little fun here.
Is he gonna eat it?
All right.
I've been there. Forever.
Let's get you guys to try this one here. Okay.
Okay.
Just gonna pause. All right. So if we solve for p, we get 3 over 2, which is just 1.5, right? Which is positive. And if you plug that in for your x value to solve for y, that'll give you your q. So 1.5 squared
2.25.
is it 2.25? My vertex is 1.5 and 2.25.
No.
No?
1.5 squared is 2.25.
Oh, okay. I thought you were giving me the answer, Carson.
You asked me what it was squared.
Oh, I thought you were just shouting the answer. What's the answer? What'd you guys get for a q value?
1.75.
1 point, even better. 1.75. Okay, so there's my vertex. So I'm at 1.15, which is about here, and 1.75 would put me right about there. Now, my graph opens upwards, and my y-intercept is at 4, right? Which is right here. 0 and 4.
Oh.
So my graph, if it opens upwards, and this is my vertex,
Oh, there's no x-intercept.
That's why I couldn't.
That makes sense.
right. There's no x-intercepts this time.
The first value or the a value is like what we look at for the see if it goes up or down, right?
Yes. Yeah. Always, yeah. Check your A values. So, x-intercepts. Because, yes, if you look at it, you think, okay, factors of 4 that give me 3, well, that's obviously 4 and 1. But then you got to play around with it. How do I get negative 3 and a positive 4? You just can't. So there's no x-intercepts. My axis of symmetry. Like so. Right? Down. Graph in half. Domain. Hopefully at this point I can stop stating what the domain is. You guys just have, if anything, just memorize it. Don't ask me why or how, just do it, okay? It's one of those things in life you just do, okay?
Okay.
My range, though, we'll talk about that a little bit. My vertex 1.75 is my minimum value, so y has to be
Greater than
or equal to 1.75. Okay. How are you feeling so far?
Good.
Yes. All right. Let's try a word problem.
Oh, Mr. Weapon.
Yep. Wednesday.
It's Wednesday?
Yeah.
All
right. Now, this word problem, these are the ones, we'll start off with these ones for today, where I give you the equations. All right, because if you're given the equation, you can solve for stuff. Later on, by later on I mean tomorrow, you're going to come up with the equation, which if you guys remember is the tough part. Okay, but for now, easy peasy. All right, so a stone is dropped from a bridge over the Peace River. The height of the stone, h meters, above the river to t seconds after it was dropped is modeled by height equals 20 minus 4.9 t squared. All right, so what we want to do is we want to graph this function. So they took a stone and they threw it off. So here's my y-axis, here's my x-axis. Now, my y-axis is represented by height. My x-axis is time. Okay. So looking at this equation, what's my y-intercept? What's my c value?
20.
20, right? Okay. So it's going to look something like this. All right. Can I have anything in the negative time? No, because you can't go back in time.
So you have one x intercept.
Yes, one x-intercept. Technically, like you could extend it and find something, but it doesn't exist in reality. Could I have a negative height though?
If it goes under, I guess it goes under the water.
Right, it goes up below into the water. Okay, that's what that represents. Do you guys take that in Science 10, like what a negative distance means or a negative acceleration or anything like that?
I don't think so.
Okay, like a negative height would mean it's below, or it's like
We did that with mirrors.
hits the
Yeah,
ground.
we kind of did that with mirrors.
Okay,
A little bit.
like a negative acceleration usually means it's falling. Those sorts of things. Like a negative direction usually means backwards or below something, below a reference point. Now, we want to find out a few things here. When did the stone hit the river?
After 4.9 seconds.
Not necessarily. The stone's going to hit the river at here, right? What is that technically on my graph?
Your x
intercepts, right? Okay, so that would be my x-axis or my x-intercept. Yeah. All right, so I'm going to show you guys how to solve for that here with this equation. So when that happens, what does my h represent? Or what's my height going to be? Right, so we know that h equals 0. So if I do that on the equation, it looks like this. 0 equals 20 minus 4.9 t squared. So what I need to do now is I need to solve for t. Okay. So to do that, I bring the 20 over to the other side through subtracting it. And then I got to divide by negative 4.9.
Can you scroll up a little bit?
Sure. Sorry, am I going too fast?
No, I just didn't get the original equation.
It's just this here with an H instead of a 0.
Okay, it's all good.
Can I scroll down again? Just let me know, guys, if I'm going too fast. It's totally fine. So now I divide by negative 4 point. So negative 20 divided by negative 4.9.
4.08.
4.08. Good. Now I take the square root of that.
2.
Right. You know it's going to be close to 2. Good. Now technically, if I take the square root of something, it could also be a negative value too, right? But is that going to happen here? No. So we know that my time was 2.01 seconds. Does that make sense? Okay. Now, for this one, it gets a little trickier. What's my domain for this question?
Oh, it's everything positive. So is that a whole number?
No.
Or
All right.
is it not an R? It's different.
So we know for this one it has to be positive, right? Now technically my graph ends here. I didn't draw it into the water because we don't know what that represents. We don't know what that looks like here. So my graph starts at 0 and ends at
0, 1.
right. So I would say my domain equals x, little squiggly, such that it starts at 0 and x is less than or equal to.
Oh.
It's in between these values.
We have to do that.
We've done it before in the past.
The X is like that.
All right. Real quick, okay, we got like 3 minutes. I'm gonna throw one more out to you guys. A question about this one. We'll call it D. What is the stone's max height? Question. What?
Good question.
Oh, what the?
What the stone? What the stone?
What is the stone? There we go, max height. Sorry. All right, so where's this max height going to be? What point of the graph? The vertex. Good. Could we find another point on the vertex? Maybe not the height, but could we find the time that happens at first? Yeah, that's my p-value.
Oh.
Right? So my p-value equals negative b over 2a. Now, what is my b value here?
0.
0. So what's my max? So what time is that going to be at?
0 seconds.
0 seconds. So technically,
Still holding it wrong.
so technically, what happens? Like I drew it so it looks like this, so it looked more like a parabola. But really, what happens is it just went like that. Okay, I just drew it kind of funny. Yeah, whatever. So because it's 0 over 4.9.
Did he drop the rock or did he throw the rock?
Good question. It's dropped.
Oh.
So, but whatever, it's fine. Don't go back and draw it again.
Drop rocks like
You
this.
said he kept on throwing it, so I believed you.
Oh,
That's why I drew it like that.
throwing or dropping is all whatever.
See, if I had my own page, I would have read it.
All right. So, what would be its max height then? If my p-value is 0,
20.
20, right? Max height.
I was being stupid. Like, would it not just be 20?
Yeah, it's just 20. Don't overthink this stuff. All right.
You did.
You totally did. All right, and that's all you got to do there. All right, so we'll call that